we have a triangle with a pair of parallel sides, we have segments that are divided proportionally. There's many different proportions that we can write, and that's kind of the main idea we talked about in class with this lesson, is that even though there are many proportions that will work, now that doesn't mean everything will work. We still have to be consistent with how we set up our proportions, but there's not just one right way to do these. So let's take a look at a few proportions we could write to find the length of side YZ. I'm going to go ahead and throw an X on that side. Even though there's an X in the diagram, I'm going to use X to represent that length. One proportion that we could write is simply 35 over X is equal to 44 over 36. That's probably the proportion I would set up. From there, we can simply cross multiply and divide to solve this. I trust that you guys are able to do that, and so I'm just going to jot down my answer of about 28.64. But what I really want to talk about is not just getting that answer, but rather the different proportions we could have written to solve this. That's the proportion that I would use, and I'm consistent in the sense of I'm setting up, let me get a different color here, I'm setting up this 35, which is part of a side of the triangle, that's not a complete side, over this other partial side. So I'm matching those two sides up, and then 44, which is a whole side of the small triangle, over 36, the whole side of that, the other side, the other whole side of that triangle. So this proportion is consistent. Now, like I said, there's other proportions that could work as well. For example, if I tried to do 35, which is a partial side, over 44, which is a full side, I just have to make sure the other side matches up. So 35 was a partial side, that matches up to X on the other side, and then over 36. So a completely different proportion, but one that would also get you the same exact answer. Now, even another way to do this problem is to not use those partial sides at all, but rather to use entire sides of triangles. So for example, if I were to find this entire side of the triangle by adding those pieces together, I can see that those add up to 79. Watch this proportion I could set up. I could match up this full side right here, the 44, matched up to that entire side of the large triangle, 79, and then as long as I'm consistent, I can match up this side right here, the 36, which is the full side of the smaller triangle, over the full side of this triangle down here, which would be X plus 36. Now, I think this proportion would be harder to solve, in my opinion, although if we did solve it, we'd see we would get the exact same answer. So again, the point of this problem wasn't to make it more complicated. We could keep it real simple like we did, but just to show you that there's many proportions you could write, but that doesn't mean everything's going to work out. Just make sure your proportion is consistent. We can also do the reverse of what we just did and use proportions to tell if two line segments are parallel. In this case, we don't know if PS and QR are parallel. Now, it looks like they might be, but of course, judging by looks does not mean that that makes them parallel. Here's how we can use proportions to do this. Let's set up a proportion. Again, there's many that you can set up. The one that I'm going to set up very simply is just going to be 90 over 72, which is a full side over a full side. And then I'm going to match that up to 50, which is a partial side, over 40. There's no variable to find this time. We know all the segment lengths. All I want to do is tell or figure out if this proportion is true. One really easy way to do that is just to cross multiply and see if you get the same thing on either side. So cross multiplying this way, 50 times 72, I come up with 3,600. If I cross multiply the other way as well, 90 times 40, that's also 360. Or 3,600, I'm sorry. So because those do come out to be the same thing, that proves, yes, these two lines are parallel to each other because those triangles are divided proportionally. We can extend this idea of parallel lines and proportional segments even further and talk about these kinds of problems, which I call roadmap problems. They look like sort of streets on a map, I suppose, in a city. And once again, as long as we have parallel lines, we have segments that are divided up proportionally. So we're asked to find the length of this piece right here. Once again, there's many proportions you can write. Now, that doesn't mean every single thing you write will work, but as long as you're consistent, your proportion should be fine. I would keep it really simple and do 16 over 15, which are those two pieces right there. That would have to be proportional to X over 18, those segments right there. Once again, I was consistent in how I set it up. It's not the only way I can do this. In fact, let me set up another way just so that we can see a couple examples. If I tried setting up the proportion this way, I could set up 16 over X. And the reason I like to trace this out is because I usually just kind of check visually to make sure that I was consistent in how I set this up. So 16 over X should match up to 15 over 18, those pieces down right there. Now if I wanted to add segments together, I could do that, although I think that makes it a little more complicated. So there's two completely different proportions. You'll see though, if you solve these by cross multiplying, you're going to get the same answer no matter which one you solve, and that's an answer of 19.2 for that missing segment.